Hello everyone, welcome to this session. In this session, we are going to solve the problem of minimization of DFA. So let's begin. This is a given DFA problem. We will solve this problem step by step. Let's go. Step 1. Remove all non-reachable states from start state. So let's check from start state. A is reachable to B, yes, it is reachable. A is reachable to C, A is reachable to D from B, and A is reachable to E from C, and A is reachable to F from C or from B, D, F or from B, D, E. So any of that.
Step 2. Mark as X for the pair PQ in the table if P belongs to final state and Q does not belong to final state, or if does not belong to final state and Q belongs to the final state. It is one of the states should not belong to final state and one should belong to the final state. Let's look into the table. AB, take the pair AB. A does not belong to final state. B also does not belong to final state, so it is not marked. C. Next is AC. C does not belong to final state, whereas C belongs to the final state, so it is marked. Next is AD. A does not belong to final state, whereas D belongs to the final state, so AD is marked. Next is AE. A does not belong to final state, whereas E belongs to the final state, so AE is marked. Next is AF. A does not belong to final state, whereas F also does not belong to final state, so AF is not marked. Next, BC. B does not belong to final state, whereas C belongs to the final state, so BC is marked. Next is BD. B does not belong to final state, whereas D belongs to final state, so BD is marked. Next is BE. B does not belong to final state. E belongs to the final state, so B is marked. Next is BF. B does not belong to final state. F also does not belong to final state, so BF is not marked. Next is CD. C belongs to the final state and D also belongs to the final state. So both the states are entering to the final state, so it is not marked. Next is CE. C belongs to final state. E also belongs to final state. Both are having the final state, so it is not marked. Next is CF. C belongs to final state, whereas F does not belong to final state. So CF is marked. See here in this table, CF is marked. Next is TE. T belongs to the final state and E also belongs to the final state. So DE is not marked. Next is DF. D belongs to the final state. F does not belong to the final state. So DF is marked. Next is EF. E belongs to the final state, whereas F does not belong to the final state. So EF is marked, as you can see in the table. Step 3. For each unmarked pair PQ and for each symbol 0 belongs to the set of symbols, find transition P, 0 equal to R and transition Q, 0 equal to S. If the pair RS is marked in the table, then mark in the table PQ. Let's see the table of unmarked states. Here AB is unmarked. So A on accepting 0, it goes to the state B, and B on accepting 0, it goes to state A. Check whether PA is marked in the table. So it's not marked. So now see with the input 1. A on accepting 1, it goes to C. B on accepting 1, it goes to D. Check whether CD is marked in the table or not. CD is also not marked, so we can't mark AB. Next, go to the next unmarked pair, AF. AF, whether A on accepting 0, it goes to B. F on accepting 0, it goes to F. So we can see in this diagram, A on accepting 0, it goes to B. F on accepting 0, it goes to self, self state. So check whether PF is marked. So BF was not marked earlier. Next to CF. This CF is how it is. A on accepting 1, it goes to state C, and F on accepting 1, it goes to state F itself. Since CF is marked, was marked earlier, so we can one is unmarked state PF and one is unmarked state, so mark AF. Next is BF. B on accepting 0, it goes to A, and F on accepting 0, it goes to F itself. Next, AF. So let's check whether AF is marked. Earlier it was not marked. Go to the next input 1. B on accepting 1. See here, B on accepting 1, it goes to D. Next, F on accepting 1, it goes to F itself. So BF, check whether BF is marked or not. Sorry, DF is marked or not. DF is marked and AF was not marked. So one was not marked and another one was marked. So mark AF. Next is CD. Since both the states are belonging to the final state, so this cannot be marked. Same as CE and DE also. Step 4. Step 4. Repeat step 3 until no more marking can be made. So we have to see the unmarked pair again. Next iterations we have to go on doing it. So here AB is not marked, yet CD is not marked, C is not marked, D is not marked. As I said in the previous slide, that C, D, C, E, D, E, these are all belonging to the final state, so it cannot be marked further also. So now check whether AB can be marked or not. AB on giving 0, it goes to BA, and on giving 1, it goes to CD. So BA is marked or not now? BA is not marked. CD. Check whether CD is marked or not. So it's not marked. Both are not marked. So we can't mark AB. That's all. No further we can do the step 3 iterations. Next is step 5, which is the final state. In this step, we have to combine the unmarked states and draw the DFA. So from the previous slide, we got that A, B, C, D, D, C, and D, E were the unmarked states. Since C, D, C, D, E, and E, D are all belonging to one another, so we can combine this C, D, E in one state. Then one more is the left one is F. Now check A on giving the inputs 0 and 1. A on giving 0, it goes to B. So B is here itself, so give the self loop. And A on giving 1, it goes to C. So it goes to next state on giving 1, C, D, E. Next, check for B also. B on giving 0, it goes to A. Since already we have done the self loop, no need to do one more self loop. Next, B on giving accepting 1, it goes to D. So B on accepting 1, it goes to D. Here already we have done for the A. So here also no need to do one more time. Next, check for C inputs, C, D inputs. C on accepting 0, it goes to E, and accepting 1, it goes to F. So on accepting 0, it goes to E, so that is the self loop. And on accepting 1, it goes to next state F. Next, check for D. D on accepting 0 equals to E, so it's a self loop. Next, D on accepting 1 equals to F, that is the next state. D on accepting 1 equals to F. Next, E. E on accepting 0, it's a self loop. So here already self loop is there. Next, E on accepting 1 equals to next state F. So E on accepting 1 equals to F. Now check for F input. F on accepting 0 and both 0 and 1, it goes to the same state. So F on accepting 0, 1, it will be on the same state F. That's it. This is how they minimize DFA. Thank you.